Following on from the previous video, we got to this stage here where we would start out with our general power series, apply this transformation, so that would look something like this, and then demand the first derivative of this to match up with the first derivative of this, the second to match up, third to match up, and so on. This purple line here would slowly map on top of the red line. So the equation for this purple line here would be our Taylor series. So our Taylor series would look something like this. So we've seen this, and you should know this by now. So our Taylor series will take this form where you have x minus 2 to the power 1, x minus 2 squared, x minus 2 to the power 3, and so on. But here's the thing: we are trying to come up with this Taylor series for this function centered at 2. So this is our solution here. This is what we're trying to obtain, but we want to develop a quick way of doing it, because our traditional slow way of doing it would be to start out with this, apply this transformation. That will mean you move everything across by 2, and then differentiate this, and then here differentiate this. This process takes a long time because you've got to differentiate this, you've got to differentiate this, you've got to differentiate this, and then you've got to differentiate this, and so on. Instead, make use of what we already know. We know this series here. We've seen this series because right from the start, we've seen this table before. We are going to make use of this, and make use of this to come up with a Taylor series centered at 2. There's a quick way of doing it rather than having to differentiate it again and again and again. So this is our solution. By taking the long route, we obtain this solution. But we want to develop a quick way of obtaining this solution here. So looking at this series, which we've seen, if you look at our solution here has x minus 2 because it's centered at 2. X minus 2, and so on. So by making use of this, if you simply put, let's say if you put x to the power 3, then this will be x to the power 3, x to the power 3, x to the power 3, and so on. But the thing is, this is our solution. By taking the long route, we came up with this solution. But if you look at the solution, you've got x minus 2, x minus 2, and so on. But if you simply put x minus 2 in here, so that would imply x minus 2, x minus 2, x minus 2, and so on. If you do this, it wouldn't give you us our solution because well, if you see, if you get a graph plotter and plot this series, you will get something looking like this green line. But the thing is you don't want it to map on top of the green line. You want it to map on top of the red line, because ultimately we start out with, ultimately we want to map on top of this red line. We don't want this green line. Remember, the red line is 1 over 1 plus x. So we would start out with our general power series, apply this transformation. That would then move it across by 2, and then by making the demand that the first derivative to match up the first, second derivative to match up the second, so on. This thing here, this general power series will slowly map on top of the red line. That's our solution here. But then by you simply putting this, by you simply putting x minus 2, x minus 2, x minus 2, and so on, what you're doing is this: you start out with the general, shift it across by 2, and then you actually map on top of this green line here. But it's not the green line that you're after. It's not the green line that you're after. It is this red line here. You see, going back to here, we are trying to seek this solution here. But by making use of this, if you simply put x minus 2 into here, you would get something totally different. Because this is what we're trying to seek. We are trying to seek 1 over 1 plus x. But then by you putting x minus 2 into here, this is no longer the same as this, but it is this that we're trying to seek. So you can't simply put x minus 2 into here. What you can do is this. But don't forget, this is the solution that we're trying to seek. We still want this x minus 2 in our solution, x minus 2. But if you simply put x minus 2 into here, you would get something totally different from what we're trying to seek. This is what we're trying to seek. But the problem is we still want the x minus 2. We still want the x minus 2 in our solution. We still want the x minus 2 in our solution. So the trick is this. Hang on, the trick is this. You put x minus 2 into here. That would mean x minus 2 and so on. But then you manipulate this because you still want to maintain this thing here. This is what we're trying to seek. You still want to maintain this thing here. So you put x minus 2. Hang on, you put x minus 2 into here, and then you immediately that will then give you this 1 plus x minus 2. But then you immediately add 2. So now this is exactly the same as this. But the trick is to leave this alone, merge this with this. So that will then give you 1 over 3, and then you've got your x minus 2 in here. So now this is exactly the same as this, but just written differently. The beauty of this is that you still got your x minus 2 in here. And remember, when we're trying to seek a solution here, we do want this x minus 2, x minus 2, x minus 2, and so on. But the good thing is that this is now exactly the same as this. So hang on. So I will continue in the next video.